Good morning and welcome to the 29th annual exhibit of hydrogen fuel cells here at the Hanover Fair in 2023. It's been 29 years of interesting conversations. One person who's been here regularly to tell us about the newest developments is Professor Andreas Friedrich, Head of Department at Deutsche Luft- und Raumfahrt, DLR, known in English affectionately as the German Aerospace Center, and we'll be discussing modular fuel cell and electrolyzer technologies and their scale-up possibilities. Please welcome with me Professor Andreas Friedrich.
Thank you, Brian. Hello.
So, Professor Friedrich, viele haben den Stand schon, oh, it's English, sorry, what am I doing? Many people have already seen your booth, which is right in that direction there, but maybe you could tell us a bit about the German Aerospace Center and why it's had this long relationship with the fuel cell industry.
Yes. So the German Aerospace Center is a large research institution in Germany. The traditional priority areas are space and aeronautics, but already 60 years ago it expanded into energy topics and also terrestrial transport. So these are the priority areas, and now we have also security and digitalization as new areas. So we are a large research center that came from the space area where hydrogen was the fuel of choice, and therefore hydrogen technology was developed, and when the energy applications become important, we entered into electrolysis and later on into fuel cell technology.
It's an interesting model. It's not from the Earth to the stars, it's the other way around, the progress. Tell us a bit about the center and the department you work at and the applications they work on there.
Yeah. So my department started with electrolysis about 55 years ago. So we have a core expertise in electrochemistry and electrochemical energy devices, and therefore the areas where we are active are fuel cells, electrolyzers, and batteries, because these are our core technologies. And you need them in all areas of DLR.
Yeah, these are all important applications, particularly for renewable energy. We need some examples here, of course, because we're now really interested in applications that drive the expansion of hydrogen consumption. Yeah. What are the opportunities and what are the applications you are working on right now that are going to change this?
Yeah, so we are presently very interested in applications which are very difficult to demonstrate just with battery technology. For example, ships, trains, and trains in areas where you don't have an electrified grid, and also aircraft. So aircraft is a very important topic for us, and we are developing technologies for aircraft, and we also demonstrated on small-scale aircraft with fuel cell technology. And now we want to go a step further, and I want to explain it. So right now, we can demonstrate already fuel cell systems in the megawatt area, which is needed, for example, for aircraft, even larger, 60 megawatts for ships, for example. But you need a lot of systems in parallel to demonstrate the application, and this is not the optimum. So the optimum would be to have larger modules with less peripheral components, so blowers, less peripheral components to keep the system running. And therefore, we are very much into a strategic project to demonstrate fuel cell technology, for example, in the megawatt range on the module level. So we need to increase the areas, we need to increase the size of the cells, and we need to keep also track of all the system components and electromagnetic compatibility and electrical properties. And this is quite challenging, and this is the step we are doing right now.
I find this interesting that we're moving towards the topic of a 1 megawatt system. We need to be clear about this. As we travel through the fair, you'll have a lot of people that are providing megawatt facilities for generation of electricity using hydrogen. They're a dime a dozen, but the interesting thing about that is when you look inside, They're actually built of several smaller stacks.
Yeah.
Each stack requiring its own, it needs to be serviced with, there needs to be vapor consistencies, water supply,
Right.
blowers, and so on and so
Blowers.
forth. And we need detail here. This complexity with all of these individual modules, what does it do? Does it change? If you make it larger, does it make it lighter? Does it make it easier to manage? Does it reduce the size of the unit overall? What are the advantages of having a megawatt stack?
Yeah. First of all, you save a lot of peripheral components because each smaller module needs its blower, needs its humidifier. So this, of course, there you have a lot of volume and weight that you can save by going to larger modules. Secondly, also, of course, the modules itself, you need less material when you build larger. And we think that the 1.5 megawatts as a core technology, fuel cell technology, is the ideal size for power size for our applications.
So we get the idea of the savings potentially there with this larger stack. What about the application side? This is obviously, engineers don't get the idea, let's do something larger just for the sake of doing it larger. That is, there are specific applications that are cheaper, there's a larger business model, or lighter, there is a new potential application. There has to be a business model or a application behind this interest in the larger set. What are those applications?
Yes. So it actually started with the aircraft application in our case. So we demonstrated small-scale aircrafts with fuel cell technology, demonstrated that they are possible to operate at high altitudes, and did all the fundamental work to develop them. But then now we have a startup company called H2Fly from a person, a scientist of DLR, Mr. Josef Kallo. Perhaps some of you know him. And he started this startup company that wants to go to a 40-passenger aircraft. And this again, looking at this analysis, leads us to the requirement that we need this 1.5 megawatt modules. So that we have a good power performance, power density for the aircraft application.
There are many ways of justifying the necessity for these new applications. I just want to refer, we'll get to the ships, of course, but I want to refer to the flying proposition. Everyone wants to take off, but what are the drivers behind this? We know that conventional fuels for planes are not really good for the atmosphere. That could be one motivation, or it could be simply a cost benefit, or a combination thereof. There could be special tariffs on fuels because the fuels are not good for the environment. What is driving this interest in aviation?
Yes, so we think that aviation is an interesting area because, of course, we have an environmental impact now with fossil fuels. You can think of going to e-fuels, of course, in the future, using combustion engines. But then you still have emissions, local emissions, that are also in the high altitudes are very dangerous or not very good for the environment. And otherwise also hydrogen for smaller aircraft would be an ideal case in our opinion because it's emission-free, but also provides a sufficient range for mid-size ranges for the aircraft. So and we think that this could be a way of having environmental friendly aviation in the future, smaller aircrafts using more regional airports, but without, say, compromising the climate by doing that. So that's our vision.
Is this in competition with the trains, or do you also have applications that allow trains to operate on hydrogen?
Yes. So we were involved in the project with Alstom, so we have experience in the train application as well. And this is again an area where you need large powers, and the module we are developing now for the aircraft first, but can also be applied to the train application and also to ships, where you even need, in general, larger power ranges. And
So potentially in the future, we will have the option. I think everyone knows that in Germany, we do have a guilty conscience when we fly from Bonn to Hanover, because we really should take the train. But the question could be later, do you pay extra to get there faster? Or save a few dollars and get there a bit slower?
So when you look in the future, so I think that autonomous flying, of course, is already possible and will become a possibility. And if it's not environmentally, has no environmental impact, I don't think you have to have a bad conscience by flying with hydrogen, really, green hydrogen, of course. And that's our motivation. And if we develop this technology, we can also apply it to the other areas as well, which are very difficult to realize with battery technologies. So battery technologies just has not enough energy density, energy content.
On your stand, which is D13 just over there, you have a model of a ship. And the ship looks like it's something for passengers, but I'm sure the hull could be repurposed for a number of things. What is so sensitive about the use of diesel fuels in the shipping industry, and why is that such a large business model right now?
It's because these are cruise ships. We have a project with cruise ships, and the cruise ships have a very strong environmental impact in the area of the haven, so
the ports or harbors.
The ports, sorry, the ports, and so this is actually causing a lot of local emissions there, which are leading to problems or exclusions of cruise ships to certain cities, and that's why the cruise ship operators are looking very much to lowering their environmental impact, and of course using, for example, synthetic fuels or fuel cell technology with high efficiency improves this environmental impact dramatically.
This for me is an interesting thing because virtually in any area where people want to look at the nature from a ship, the very ship itself is jeopardizing the local ecology. So if you are talking to people who service the tourist industry in the fjords, they don't want these diesel-driven ships coming into the fjords at all. And it's very interesting as well because it adds this notion of pollution is not generalizable. It's sometimes very specific to where you are. The business model for flying, those emissions have a different effect when they're emitted higher up in the atmosphere as opposed to being emitted on the ground. So I don't know, how much time do you spend? Obviously the model is based on a technology that works. But the second, it's not simply the benefit, it is the business case, is literally that alternatives are limited. We have to, everyone knows this in Germany, phase out diesel delivery vehicles because the fine particulate matter in the air reaches over critical levels, and legally they should shut traffic down. So what is the business model in terms of how carefully do you study the environmental effects and the legislation to say, oh, this is going to be necessary?
Yes, certainly we're there. Actually, the DLR cannot act alone, of course. So we are within a community of interested groups that are pushing regulations forward. And we need to have the environment, the regulations in order to enable these applications. And with that, DLR is doing we are working together in several different institutes. So my institute is a Technology Development Institute, but we have also other institutes that look more into the system analysis and also on the impact that technology has on environment and energy efficiency and so on. This is, in general, the ecosystem that is necessary in order to bring new technologies forward today. So we are working there in collaboration with others inside DLR, but also industry, of course, industrial partners. and international organizations that look, for example, into the marine regulations and so on.
We always think, when we think of this technology, of Machbarkeit, what is doable and what is affordable. Those two equations. I remember years ago when people thought of like flying with fuel cells. No, it's not going to work. It is a prospect. But the affordability equation, this is another benefit of your large-scale stacks, isn't it?
Yeah.
We have the precious metal investment necessary in order to build these things.
Yeah.
What effect does that have on the large-scale fuel cell?
Yeah, that's another topic where we are very strongly working on, is to reduce the critical materials in these devices. So this is another thing that we have to be very careful that we don't have technologies that consume too many critical resources. The European Commission has published also the basis where they see which are the critical materials. Noble metals, of course, are belonging to that category, and we are, in parallel to demonstrating the large-scale modules, working on reducing the noble metals as a long-term activity. And for example, this we are not doing only for fuel cells, we are doing also for electrolyzers, and we actually succeeded recently to reduce noble metal content of PEM electrolysis, so the iridium content to a factor of 10. So we think that this makes the PEM electrolysis technology sustainable.
Yeah, we started with electrolyzers in your company history. We're now concluding. By the way, we have time for one question, if there is a question from the audience. But we're pretty close to the end of our discussion here. My final question is in regard to electrolysis. We need to get away from the industrial base of the gas. People are well aware here in the industry that about 1% of the hydrogen consumed today is actually green hydrogen that is produced through renewable energy. And obviously this has to change. Among other reasons, because Germany doesn't have the supply of hydrocarbons from which to create gray hydrogen, and we need energy security. And in this instance, electrolysis is really fundamental. We have to scale up. It's unimaginable almost how we have to not only replace the electric grid, I'm talking about the kilowatt hours consumed in the electrical grid with renewable energy, but we also have to address the far larger portion of energy that is consumed via hydrocarbons. So I need basically your professional opinion on how long this scale up is going to take. Things have sped up radically, unexpectedly in the past 10 years, but how are we going to get to zero emissions to the hydrogen economy?
Yeah, this is a very difficult question you're asking. And actually, I've seen some presentations before which had addressed that. Essentially, in my opinion, it's the incentives that need to be in place. I think it can move very fast if the incentives are in place so that private money, private capital is mobilized. So right now we are still, I mean, that's not bad for our purposes, which as a research institution, but just relying on demonstration projects is not accelerating too much the implementation, the deployment. So having incentives in place that make business cases, this is the accelerator that is necessary.
Okay. Well, on that note, it's been a very informative conversation. As always, we've done this before at the fair. I hope to see you back next year.
Yeah, okay.
I've been talking to Professor Andreas Friedrich, who's head of the department at the DLR German Aerospace Center, and we've been discussing modular fuel cells and electrolyzers, technologies, and their scale-up possibilities. Visit the booth.
The booth D13, if you want more details, come to our booth.
Exactly. The conversation shall continue.
Yeah.
I'm sorry, we don't have time for a question now, but you can directly address the question to Dr. Friedrich, who's returning to his booth. Thank you.
Yeah.